Okay, so we are introducing a new part to this chapter. We are going to go over parallel and perpendicular lines. Okay, so the basic vocabulary of these is parallel lines are lines that never intersect. Okay, parallel meaning they're going the same direction, but they're never going to cross each other. They're just going to be parallel to each other. Algebraically, mathematically, this means that the slopes, which is our m, our rise over run, our slopes are the same. Okay, and we'll talk more in detail about this. Perpendicular are lines that intersect, so these do cross, but they intersect at a 90-degree angle. Okay, meaning a perfect 90-degree angle, intersect at there. So we have a picture up here visually. Parallel means the same direction, never cross. Perpendicular means they intersect at a perfectly 90-degree angle. Algebraically, perpendicular, they don't have the same slope. They actually have opposite reciprocal slopes. Okay, and that word should sound familiar because what I mean by opposite reciprocals, okay, is opposite meaning if it was positive, then the other one's negative. So opposite. Reciprocals means flipped. So let me show you some examples, okay? If I look at number 1, this original slope is positive 3/4. Well, the opposite of positive is negative, and the reciprocal of 3/4 is 4/3, because all I did was flip it. Number 2, the opposite of positive 2 is negative 2. Now the reciprocal of 2, keep in mind, 2 as a fraction is 2 over 1. So the reciprocal of 2 is negative 1/2. Okay. Number 3, the opposite of negative is positive, and the reciprocal of 7/8 is 8 over 7. Okay. Number 4, the opposite of positive 1 is negative, and the reciprocal of 1 over 1 is 1 over 1. So this one's kind of a special case, and that means just negative 1. Now number 5 is a special one, okay? Because there is no opposite of 0, because 0 doesn't have a sign. It has no positive or negative. But if you remember what 0 slope looks like, that is a horizontal line, okay, on my graph. Well, the opposite reciprocal of that is the vertical line, and the vertical line is a slope of undefined, okay? So let's first go over, see if we can identify. That's all we're doing today, is seeing are they parallel, same slope, perpendicular, opposite reciprocals, or neither, because it can be neither. They don't have to be one or the other. So we're first going to do this by performing linear regression, okay? So for number 6, we're going to type these coordinates. So first I'm going to do AB. Okay, you can't do it all at once. So first I'm going to type in negative 2 on the left, 3 on the right, 2 on the left, 6 on the right. So I'm taking care of this first 2 first. Stat over to calc, number 4, enter, 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 enter. So AB slope, again, we're just focusing on the slope, is 0.75. Now we cannot leave it as a decimal because opposite reciprocals deal with fractions. So 0.75 as a fraction, if I perform alpha y4 on here, converts it to the fraction 3/4, okay? Now we're going to do the same thing with these 2 points. So we're going to go back to stat, delete, 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 delete. Negative 1 on the left, 0 on the right, 3 on the left, 3 on the right. And I go to stat, over to calc, number 4, enter, 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 enter. The slope for line CD is 0.75 as well. And we've already converted this to a fraction, which we already know is 3/4. Okay, did you look at them? They are the exact same slope. And since they are the same slope, we call this parallel. Or you can use the symbol of a double line, parallel lines. Okay, let's do the same exact thing for number 7. So first thing we're going to type in is our first two coordinates. So 0 on the left, 2 on the right, 5 on the left, 4 on the right. I'm going to go stat over to calc, number 4, enter, 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 enter. The slope for AB is 0.4. Again, we don't want to leave it as a decimal, so 0.4 alpha y4, oops, did not like that, is 2/5. Then I perform linear regression on CD, so delete, 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 delete. 1 on the left, 8 on the right, 3 on the left, 3 on the right. Stat over to calc, number 4, enter, 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 enter. The slope for CD is negative 2.5. Again, we don't want to leave it as a decimal, so negative 2.5 alpha y4 is negative 5/2. Now look at it, okay? At first glance, they don't look anything alike, so I know that they're not parallel. Then we want to check if they're perpendicular. Perpendicular means opposite reciprocals. Well, isn't positive the opposite of positive negative? And isn't the reciprocal of 2/5 5/2? So since these are opposite reciprocals, these are perpendicular. And if you don't want to actually write the word out, we are going to use the symbol like that. Looks like an upside down capital T. Let's do the same thing for number 8. So it's the same over and over again. Okay, so linear regression, which means I go to stat. I'm going to type these first two coordinates in, negative 1 on the left, 8 on the right, 2 on the left, 6 on the right. Stat over to calc, number 4, enter, 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 enter. The slope for AB is negative 0.6 repeating. Ignore the 7 at the end. I do not want to leave it negative 0.6 repeating. But don't just put negative 0.6. You need to put negative 0.6666 alpha y4, enter. So the slope of that is negative 2/3. Then I perform the linear regression of the second set of points. So negative 1 on the left, 2 on the right, 3 on the left, 3 on the right. Stat over to calc, number 4, enter, 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 enter. The slope of CD equals 0.25. If I convert that to a fraction, 0.25 alpha y4, it's 1/4. Okay, so look at these two examples. They're definitely not parallel because they're not the same. They're definitely not perpendicular because they're not opposite reciprocals. Yes, negative is the opposite of positive, but these are not reciprocals of each other. So this would be that example of neither. It's just regular old lines, okay? Number 9, last one of these types. Stat, perform linear regression. So 2 on the left, 3 on the right, negative 1 on the left, 4 on the right. Stat over to calc, number 4, enter, 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 enter. The slope of line AB is negative 0.3 repeating. Again, I want to convert it to a decimal, so negative 0.33333333333 alpha y4, okay, is negative 1/3. Again, you have to do the negative 0.3 repeating because if you just do negative 0.3, it's a completely different fraction, so make sure you do it correctly. Then the second set of points, I'm going to do linear regression. Negative 5 on the left, 3 on the right, negative 4 on the left, 6 on the right. Stat over to calc, number 4, enter, 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 enter. CD equals a slope of 3. This one I do not have to convert to a fraction because it's not a decimal. So let's look at it. They are not parallel because it's not the same. One is negative, the other one's positive, so they are opposites. Are they opposite reciprocals? Is 1/3 the reciprocal of 3? And yes, because remember 3 is 3/1. So they are opposites and they are reciprocals. So this would be another perpendicular. And we use the symbol an upside down capital T. Okay, so that is, we use linear regression if they gave me two sets of points, okay? But since this is algebra, it's not going to be that simple. We are going to practice doing it given two equations, okay? So the first step, or really the main step, is to make sure that our equations are in slope-intercept form. which means we need to make sure that they are in y equals mx plus b form. If they give it to me in standard, then we practice solving for y. So if I look at number 10, okay, these are both in slope-intercept form because they're both y equals. So there's no converting on this one. So now I just need to be able to identify the slope. Remember, the slope is whatever value is next to x. So my slope here for this first one is 7. My slope for the second one is also 7. And since they are both the same rules apply. If it's the same slope, they are parallel. Or we can use the symbol as a double line, okay? Number 11, they are already in slope-intercept form because they're both set equal to y. Then I just identify the slopes. Remember, the slopes are next to x, so 4/5 is the slope of the first line, and negative 5/4 is the slope of the second line. If you look at them, they're not parallel because they're not the same. Are they opposite reciprocals? Well, positive is the opposite of negative, and 4/5 is the reciprocal of 5/4. So these are opposite reciprocals, which makes them perpendicular, and which we can use the symbol as an upside down capital T. If I look at number 12, they are already in slope-intercept form because they're set equal to y. Then we identify the slope, which is next to the x. So this first slope is negative 1/3. The second slope is positive 1/3. Okay, this one tried to trick me. Yes, they are not parallel because they're not exactly the same. What I mean by exactly the same is they're both have to be positive and both have to be the same value. Well, they're both 1/3, but one's negative, one's positive. These are not the same, so these are not parallel. Well, then you think, well, if they're opposites, then they have to be perpendicular. That's not true either, because yes, negative and positive are opposites, but these are not reciprocals of each other, so they're not perpendicular either. This example would be neither. Okay, they're not perpendicular, they're not parallel. Okay, if I look at number 13, they are not in the correct form because we need to solve for y. We need to set it where it's in slope-intercept form, y equals mx plus b. So we've done this before, let's do it again. They want us to solve for y. So first thing I need to do is to subtract x. So 6y equals, remember they want to put the x first, so negative x plus 30. Then I'm going to divide by 6, and I'm going to divide every single piece by 6. So y equals negative 1 over 6 is negative 1/6 x, and 30 over 6 is plus 5. So my slope is right here, negative 1/6. Then on the right side, the only thing I need to do to solve for y is divide by 3. Remember, I'm going to divide everything by 3. So y equals 18 divided by 3 is 6x, and negative 6 divided by 3 is negative 2. My slope of this one is 6. So let's ask ourselves, are these parallel? No, because they're not the same. Are they perpendicular? Yes. And the reason why these are perpendicular is because negative is the opposite of positive, and 1/6 is the reciprocal of 6. So these would be perpendicular. Or we can use the symbol as an upside down T. Look at number 14. The left one is not set equal to y, so we are going to solve. First, I subtract 5x, so negative y equals, again the x goes first, negative 5x plus 4. Y is not by itself yet until I divide by negative 1. So y equals negative 5 divided by negative 1 is positive 5x, and positive 4 divided by negative 1 is minus 4. The slope of this line is 5. That's where my focus is. On the right side, it is set equal to y, so I don't have to convert on this one. I just have to identify my slope, which is the negative 1/5. Okay, so these are definitely not parallel because they're not the same. Are they opposite reciprocals? If I did my math correctly, which I sure hope I did, then these would be opposite reciprocals because positive is the opposite of negative and 5 is the reciprocal of 1/5. So these are also perpendicular. So we could use the symbol as upside down capital T. Okay, number 15, last one. First, we need to solve for y. So we're going to subtract 3x. negative y equals negative 3x plus 2. Remember, the x goes first. Divide by negative 1 because we need to get y by itself. So y equals negative 3 divided by negative 1 is positive 3x, and positive 2 divided by negative 1 is minus 2. My slope is positive 3. Then on the right side, I'm going to subtract 12x from both sides. So I have negative 4y equals negative 12x plus 4. Going to divide by negative 4 by everything. So y equals negative 12 divided by negative 4 is positive 3x. And positive 4 divided by negative 4 is minus 1. The slope of this one is also 3. And since the slopes are the same, these are parallel. Or we can use the symbol as a double line.